Hi team, this is just a quick recording of the key things looked at in Year 9 matter in science. I'll be doing key lessons as we go. Feel free to pause and, kind of fill in the answers as you go from your slides with the blanks. So number 1 in lesson 1, we looked at what we call subatomic particles. So basically these are things in the nucleus such as your proton, your neutron, and your electrons. Okay, so the goal of this lesson was to really first learn about the 3 subatomic particles. You then want to learn about what the charge of each one is and what implications that has, where do you find them, and how are they relatively sized to each other. So let's just do a quick recap of Year 8 just to give us a bit of context before we delve into it further. Number 1, we'll start off with the atom. There's 3 subcategories that you can break it into. Element, quite easy to understand. It's really where you've just got the one type of atom. You've then got your compound and your molecules. Now, I really like the image on the right-hand side that helps explain the difference between the two. The Venn diagram really shows you that the molecules can have compounds within it, but not all molecules are compounds, because compounds have different elements involved. So in a nutshell, I know the Venn diagram can be a little bit confusing because you may notice that they've got the same compounds in twice. In a nutshell, molecules are anything chemically bonded together, more than one obviously. Your compounds are specific to having more than one atom involved in the chemical combination. Alright, so these are just some sample answers that you could have had on the bottom. Now there's a great video to watch and you just have to use this and then use the information in the slide to help you answer the next one here. And your answer should have looked something like this. You find the proton and neutron in the nucleus, which is the green and pink part here. The charge of the proton is positive. The neutron is actually neutral. In the shells on the outside that orbit the nucleus, in the space around the nucleus, that's where you find the electrons. Okay, for simplicity's sake, that's what we keep it as for now. So what's the center of the atom called? The nucleus. The 2 particles found here is the nucleus and the proton. What particle is found orbiting the center of the atom? That is the electrons, and that's a nice summary of that. Highly recommend you take the time to memorize and think about that. I really like this analogy, which is further looked into in the next video in 2 slides down. Gives you a really nice understanding of the actual sizes of these subatomic particles. Okay, they give you a really nice idea of the Melbourne Cricket Ground, the MCG, and the fact that the nucleus would only be the size of like a pinhead, and that's the majority of the mass in that one spot. And also when you think about a neutral atom, which means that it's neutrally charged, it's got the same amount of protons and electrons. Remember, down the track we'll learn about ions where it's actually no longer neutral. And it's just a nice analogy to really imagine what it would look like when you actually break down the components of the atom. Just some answers to look at from that piece and that article. Nucleus is made of protons and neutrons. Electrons move around the empty space. Most of it is empty space and they have an overall neutral charge. I have to emphasize that's for neutral atoms. Obviously in ions, cations, anions, that's a different case. And the pinhead is the size of the nucleus. Now the next video is a really great one. Really love it. It actually gives you a really nice understanding of just imagining what it would look like if you were looking at the inside of an atom. Really nice one, unforgettable almost. And this one here, after you've written down the interesting pieces of facts, for example, I loved how they gave the idea of most of it being empty space and how they showed you how densely packed the nucleus is with all the cars. Those would be my 2 facts there. This one's a really great one for the next slide here. Protons and neutrons, approximately the same mass. We say approximately. The mass of the electron compared to the proton or neutron, we say approximately again 1,836 times the mass of the electron. A fair bit of a difference there. Where do you find most of the mass? You wouldn't be surprised, it's the nucleus. And if you had to look at the mass versus the size, there's a lot of empty space there. The majority of the mass is in the nucleus. I hope that's given you a general understanding. We will go into lesson 2 shortly. Take a minute to pause and just go through those slides. You may come back to the second lesson. Now, I'm realizing for the sake of time, I'm going to breeze through the rest. Please do not hesitate to reach out and ask any questions. Lesson 2, we focused on 2 things, the atomic and the mass number. So first of all, you just want to understand what those are. First of all, atomic number is equal to the number of protons in the nucleus, and the mass of an atom is found in the nucleus, which helps explain the mass number, which is the protons and the neutrons. So we're going to learn how we can actually work out different things with the given information. For example, if I asked you for the mass number, where do you find that on the periodic table? You then want to actually say why electrons are not included in this, because their mass is actually quite insignificant. And where do you find all this information from the periodic table, which is kind of like a cheat sheet for chemistry, okay? This video, first of all, does a nice job of giving you a nice introduction to mass and atomic numbers. And these questions can then be answered. So number one, atomic number is the number of protons. I like to think of it atomic versus mass. Atomic comes first in the alphabet, smaller protons. M for mass number comes later, which means there's more involved, so protons and neutrons. Okay. Now, please remember your periodic table can vary. Generally, just a rule of thumb to make your life a bit easier, the bigger number is the mass number, which makes sense because that's how many protons and neutrons you have, and the smaller one is the atomic number. We will go into relative atomic mass in a later stage because you will notice that it's not always a whole number in some versions of the periodic table. These questions, you just have to use a periodic table. So first of all, for number one, which element has the atomic number 15? You want to actually find the one that says number 15 as you go across, and that will be phosphorus. Let's maybe jump onto question 5. The element with more than one proton than nickel is. So you want to find where is nickel, Ni. And once you find nickel, you want to jump one step ahead from here, which is copper. All right. And the last one, 9, the element with the lowest number of protons is, so you want to go all the way to the start, that is a hydrogen. Okay. Lowest atomic number. Next of all, let's have a look at mass. They all have a mass. It's the protons and neutrons. As I said, nutrients instead of neutrons, we get the idea. All right, so you just have to add the two together. Next, we then have a nice broader definition of it. Basically, protons have the mass of the atomic number. Neutrons actually have the mass that is equal to the protons. Electrons are not included because their mass is almost insignificant. You may remember from the earlier slide that they actually have a really insignificant number. Let me find that slide for you right now. It's 1,800. And is it 20? Yep, 836 times the mass. So really insignificant, not even going to bother putting it into our mass number. Okay, and an atom with 2 protons and 2 neutrons, what do you think its mass would be? Just add them together. Again, atom with 5 protons, 6 neutrons, just add them together, 11. All right. Lastly, how do you represent the atom? Firstly, we have our groups and our periods. So think of your groups as the ones going down, the periods going across wide. Again, you may want to use another analogy with the alphabet, for example, to help you remember that. And let's try the example over here with lithium. What is the mass number? Remember, mass number, not atomic number, it's the next one over, the bigger number, 7, because it includes proton and neutron. Atomic number, the smaller one, number of protons is 3. The name of the element, if you're unsure, just go to the periodic table and it should be written on the bottom, which says it's the lithium. That is the end of lesson 2. Just pause now before going on to the next one.